Hi, everyone, and welcome to a single serving of Security Bytes. Today, we'll be looking at a hack the box challenge called Compressor, and we'll be discussing why it was hackable and how to prevent it. We're looking at this challenge specifically because it does share some similarities with web apps in how it's constructed, and because we can learn about commands that are common or common tools and how we can exploit them. Okay, so the first thing we're going to do is just read the challenge description to see what we're supposed to do or what we're up against. So it says Ramona's obsession with modifications and the addition of artifacts to her body has slowed her down and made her fail and almost get killed in many missions. For this reason, she decided to hack a tiny robot under Golden Fang's ownership called Compressor, which can reduce and increase the volume of any object to maximize it according to the needs of the mission. With this item, she will be able to carry any spare part she needs without adding extra weight to her back, making her fast. Can you help her take it and hack it? Okay, so it looks like we are helping some sort of secret agent, and a competing company has some sort of tool that Ramona wants to help her be better in the field. Okay, let's see if we can hack it. So let's start this instance. Okay, we've got an IP and a port. Let's go there. Let's see what's up. Okay. This doesn't really look like a web page. We can access it though. We do get data back. So we tried it with the HTTP protocol, but we're getting this error here. Looks like a Python error. We also see these characters here. These look like control characters. But let's try accessing this in a different way. Let's use Netcat. And Netcat is a general purpose soccer tool. Let's host and port. Yep. Right. So now we've got something that looks better, and now we can actually give it input as well. Now, what does it say? It says directory to work in here. Looks like a random directory. Then there's a component list: head, torso, hands, and legs. Okay, so this is where the stuff compresses to, it seems. So we need to choose a component. Okay, let's choose head. Let's see what's going on in head. Right, so we've got a list of actions. So we can create an artifact, we can list a directory, compress artifact, change directly, clean, or exit. All right, then we see there's these commands here next to some of the actions as well. I'm assuming these might be running on the host or the backend. This is a print working directory in the list. That's fine. This is a compress. Okay, so it just uses zip to compress something. Change directory and RMRF with a star there. That's quite dangerous, possibly. Okay, so let's choose an action. Let's see what create artifact does. We need a name. Content. Let's call it bar. Artifact 2 is created successfully. Okay. What's the next action we could try? Let's do a list directory. Ooh, okay. So then this would be the artifact we just created, and it's there. That's good. Okay. What is the next action? Let's see. Compress artifact zip name options. Okay. Let's see. Insert name.zip. Okay. Let's call it foo.zip. Insert name. Okay, that's the second argument, so that might be what we are going to compress. So just foo again. Options. Don't have any options right now. Adding foo, stored 0%. Okay. Let's list it again. Okay, so we see it created foo.zip. Okay. The next action, change directory of dir name. Okay, so is it going to ask us dir name? No, it takes us back to components. Okay. Let's go back to head. Okay, the next action, clean directory. Let's do that. Okay, it just shows the actions again. Let's list to see. Yeah, the files are gone. Okay. Exit. What does that do? Does it go to the menu or invalid option? Okay. Threw us out. Okay. Let's netcat back. If we go to head, there shouldn't be anything. It looks clean. Okay, let us just do a cursory scan of the other items as well. Let's see if any of the components have a special action. That might be a clue as to what we're supposed to be doing. It also doesn't have anything different. Let's go to hands. Okay, same 6 actions it seems. Let us do the legs as well. Okay, same actions. So I don't think it matters where we go. Okay, let's go back. Let's just stay in head. Makes the most sense. Okay, so we need to hack this. So what can we do? We can list directories. We can compress artifacts, change a directory, and clean a directory. So something that stands out immediately for me is in this list directory, there are actually 2 commands running. There's a print working directory and there's a list long all, and it's separated by semicolon. So we might be able to run 2 commands somewhere and an additional command that we specify that's not in this list. Now the only place that really asks us for anything is create artifact and compress artifact. Now we don't know what create artifact does. So we can, if we create artifact, it asks us for a name. Let's say foo semicolon echo 1. Invalid name. Okay, so it throws, it quit the program. Okay. So we can't really add anything in there. Doesn't like that character. Okay. If we do a compress artifact, insert name.zip. Well, I don't have any files now, I think. Let's try it then. Let's say foo insert options. Okay, it should have a verbose flag. We'll add a verbose flag and then a semicolon to try and separate these commands. Echo 1. Oh, invalid name. Okay, so it doesn't like it if we add a semicolon. Now there's other ways to inject stuff as well and make the shell do something slightly different. Let's see if we can on this create artifact do a subshell and then foo again. Subshell is to echo 1 invalid name. Okay, so as soon as we start adding special characters, it breaks, which is not great from a user experience point of view. Could it say at least say like, okay, this character is wrong, don't use this character, take us back to the menu. It doesn't have to entirely break and throw us out. Okay, let's go to compress artifact again. Let's see if we can do something else. Let's maybe pipe this command somewhere else, see if that picks up. We don't have a artifact. Yeah, name not matched foo. So let's just create an artifact quickly. Let's call it A for ease of typing. A and A. Let's see, it does exist. Okay. So let's compress A and A. Okay, we are going to verbose flag. Let's pipe it to echo 1. Invalid name. Okay, so it throws us out. So we can't really add characters or special characters. So we're not really going to be able to break out in that way. Now there's another thing we can try. So zip utilities normally have a way to test the archive you've created. So, you know, you've selected all the files you want to zip, you've added them to the archive. Now you want to make sure that this archive can actually extract again. So basically like testing your backup. So you might be, that is not a good keyboard shortcut. That is a good keyboard shortcut. Let's see in zip what that test command is and what we can do with it. Let's see, test. They all have some sort of flag -- test. Okay. Test the integrity of the new zip file. If the check fails, the old zip file is unchanged. And with the M option, no input files are removed. Okay, so this is what we're looking for. But now right below it, we see this other command, or this other flag, unzip command. So this flag says use command cmd instead of unzip tqqt to test an archive when the T option is used. Okay, so we can actually specify which command we want to use to test instead of unzip. So let's test A again. Oh, we need to create it, I think. Now we would need to. Okay, let's create an artifact AA and compress it. We want A to go to A. Okay, so we need a big T. Right, and this flag unzip command. And we want it to be, it doesn't like that. So, okay, the command should be echo I am injected. Invalid name. Okay. Let's try again. Maybe I misspelled A. AA. This directory. It's definitely there. Try it again. So we want A, insert options, T, command, I am injected. I think it might have been a quoting issue. Ah, there we go. That's not great spelling, but we can see that it did echo there. So we are able to use this test command and this unzip command to overwrite what zip normally uses to verify. And with this, we might be able to explore this host a bit. Okay. Let's do that again. But let's explore this host a bit. Let's go 2 directories up. So we should be in head right now. I saw that earlier somewhere. Yeah, the subdirectory is some random directory and then head. So we want to go off of head, out of this. Right. Okay. Now we've got some data. We see all these random directories. So that might have been us logging in, might have been other people getting into the server. Then we see 2 interesting things. We see these Python files, so that might be the source code for this project. And we see a flag.txt. So because this is a capture the flag challenge, we are actually looking for this flag.txt, which means we have essentially owned this host. Okay, now let's just see. I'm just going to take the first 2 bytes just to make sure that that is the flag we want. So I'm going to get the first few bytes of flag.txt. Just make sure. Yep. There we go. You can see it is the hack-to-box flag format. Okay, so we can do stuff on this host now. Now, apart from reading this flag here, there's a couple of other things we might be able to do. For instance, this source code here, we might be able to exfiltrate that. Let's go AA. You want to cat. What was it called? RT facts.py. And there we've got the source code. So we can read through this and we can see if there's some other way to exploit the server as well, but this is already bad. So using this function that's been made available to us, we can exfiltrate data from the server. If we use perhaps another command like sed or echo, we might be able to overwrite source. So whoever logs into the server next will be running our malicious code. They won't actually be running this here. And we might be able to do some other things as well. If this was a web page, we might be able to deface it. It's just bad all around. So we are on this host, and we have essentially owned this host because we can get in through this zip command. So what have we found? We have found that we should not be trusting user input. If anyone can send anything to the server, we really need to sanitize what's being sent through. We can't trust the input. So we need to be very, very sure about the input we're taking and where we run actions with it on the server. So some of the things we can do to fix this, if this was our application, is to check if any run is running the test command or the test flag when they run the third one. So if you see a flag, unzip command or test, just remove it completely. Something else you can do is have a set of default options that everyone uses for this compressed artifact, and then just don't expose those options at all. Just take the two names. Something else that can be done, which simplifies the architecture a bit, and I think makes it even more safe, is remove this entirely. So whenever an artifact is created, we're assuming the purpose of this this robot is to compress things. So whenever we create an artifact, after we've given it the name and the content, just compress it automatically. So you don't expose this at all, and it's one less step. So the user experience might actually be better, apart from it just being safer. All right, so that was it for the security bite for today. I hope you have enjoyed it. It's just a reminder to please don't run any kinds of penetration tests or play around in systems that you don't have explicit permission to do so. And thanks for watching.